They go from 2 to 6. So let's go from 0 all the way up a couple of tick marks, probably 6. Okay, now let's draw our bars. This first bar of 200 has a tally of 6, so his bar is going to be 6 high. 6 high. Okay, the 300s has 5, a tally of 5, so he is going to be just 5 high, one less. The 400s have a tally of 2, so that's going to be 2 high. The 500s have a tally of 3, so 3 high. And lastly, 600s have a tally of 4, so 4 high. And on your homework, it probably won't say 6, 5, 2, 3, 4, but you can count how high each bar is. It should be 6, 5, 2. Yeah, you get the point. Okay, so we know what a histogram is. Let's keep going. This next sucker is a histogram. It says to the figure on the right, it shows a bar graph talking about rainfall in centimeters. Which month had the most rainfall? That's kind of obvious. The most means the highest. Okay, so let's look at the highest bar. Where's the highest bar? Here it is. November. Okay, so part A says which month had the most rainfall? November. Now we have to count how much it had. And they're in centimeters. So let's maybe look. We're going to have to look real close. Okay, I think this is 35. And this is 30. So we have to figure out, So we have to figure out how these are counting. I think these little ticks are counting by 0.2s. So the next is like 30.2, 30.4, 30.6, 30.8. You get it? I think every single one of these ticks goes up by 0.2. Okay, so for us, we want to know how high this bar is. Well, it's definitely 30, because it goes to the 30 tick mark, but then up a little by 0.2. And if you're asking, how did she know each of these are worth 0.2? Well, from 30 oh my gosh, I'm an idiot. These don't go up by 0.2, they just go up by 1. Moron. 31, 32, 33, 34. I'm an idiot. Okay, so this highest thing, I need to put my glasses on. Okay, so the highest, this bar does not go 30.2 high. It just goes 31. My bad. I didn't have my glasses on. Okay. So, November is 31 centimeters high. Okay. And now it says how much total. Total means add from April, November, and September. Okay, y'all are going to have to help me count because I didn't have my glasses on. Okay, so April, where is that guy? Oh, here he is. Here's April. Let me see how high that guy is. Okay, it looks like it's 24. Okay, so that's April. November, we already said it was a 31. September, where's September? Here's my guy, September. It looks like he's 5, 6, 7 high. Okay. So it says how much total rain fell in April, November, and December. Well, from those two bars we labeled, it was 34 for April. November was 31. And September was 7. And then we add them up and we get 62. And we're talking about centimeters. Yay. Okay, keep going. Let's look at this sucker below. It says seniors at a high school were asked about their preferred online social networking service. To the right are the percentages of students in the top 5 responses and those with none of the 5 responses. Construct a circle. graph for the data. Okay, the thing we need to know about circles is that the whole circle is worth 100%. Yeah. Okay. So, if I want a circle with just 56% shaded, that's going to be half the circle, almost over half the circle. So, let's draw a circle. And 50% would be like half of it, but we need maybe a little more. Okay, so all of this, I definitely did half because it's 50% plus a little bit more, so this is 56%. Okay, the next one is 24%. Okay, 24%. How much of 100 is that? 24 of 100 is kind of like close to 25% or a quarter. Or you can think to yourself, okay, this 24 should be half of the 56-ish. Okay, now let's look at this 12%. 12% should be half of that 24, so an even smaller slice. Okay, then from there, we should have a 1, 3, and 4, so maybe, oh gosh, 3%, 1%, 4%. So, if your percentage is close to half, that means close to half of the circle is 50%. Okay, then this 24% is kind of half of that half, so it's like a fourth. Yeah, and then 12% is half of that 24. So when you're looking at your homework, your picture probably will be much better than this, but just look for patterns of halves. Okay. Let's look at the next sucker. It says, the following are the GPAs of 30 students from a certain university who participated in a track meet. Draw a dot plot. Okay, we know how to do dot plots. Plots are lines that go left to right. And first we look for our lowest number. Looks like it's a 1 maybe? 1 point something? Yeah, it looks like 1.9. Okay, and then let's keep going. The last number looks like it's, the highest number looks like it's a 4.0. Yeah. Okay. So, now we need all the tick marks in between. I think I'm kind of lazy, so I'm going to maybe say this is just a 2.0, and then 2.1, 2, 3, 4, 5. Then 6, 7, 8, 9, 3.0. Then 1, 2, 3, 4, 3.5. Then 1, 2, 3, 4, 4.0. Oh, I'm too big. Oh gosh, I'm way too big. Okay. So let's draw. We're gonna have how many 1.9s? 2. Okay, let's keep going. How many 3.2s? It looks like 2. So 3.2 is 2 tick marks to the right. Yeah, let's keep going. How many 4.0s? It looks like 2. Yeah, you get the point. Okay, we'll keep going. How many 2.8s? Looks like 2. 2? So we put that above the 2.8. Let's keep going. How many 3s? 3.1s, I mean. 3.1s. I think there's 2. So you would go to 3.1 and put 2 dots. Okay, so anyway, you guys can finish that one. just remember, you stack your dots up and down. And if they repeat, you put that many dots on top. Okay, let's keep going. Next sucker. It says a class of 8th grade. Oh, it's another circle. A class of 8th graders undertook an ambitious project to compile the most dominant color of uniforms for all 449 middle school sports teams in their state this year. The circle graph to the right shows the results. Approximately how many teams are represented in each sector? Okay, approximately means we're going to round, and it tells us to round to the nearest whole number. Okay, now to figure out how many teams out of the 449 there are, we're going to take these decimals and move them twice to the left. So this 25% is going to become 0.25. And then we're going to multiply that to 449 to figure out how many teams had black uniforms. So 0.25 times 449 is 112.25, but we round down to 112. Keep going. For these white uniforms, we're going to take that decimale and move the decimal twice to the left to get 0.16. And then we're going to times it by the total amount of teams, 449. And that'll tell me how many teams wear a white uniform. Okay, and this just says round to the whole number, so 71.84 becomes 72. Okay, so in my word problem, for the black, I'm going to put 112. So let's see, there are approximately 112 teams represented by the sector labeled black. Okay, for the white, it's 72, but be careful because these boxes are out of order. Look at this. Blank teams represented by the navy blue. Blank teams represented white. That's what I need. So 72 actually doesn't go in that second box. So you have to look at the words. It says approximately blank teams represented by the sector labeled white. So that's why I put 72 in that box. And then you keep going. 0.21 times 449. 0.16 times 449. 0.12 times 449. 0.10 times 449. Yeah, you get the point. Alright, let's keep looking. We've got another circle. It says, which is the largest continent? Okay, well, whatever has the largest percentage. That's pretty easy. So, if we look at our percentages, the highest is Asia. Go Asia. Alright, let's see. Part B, it says, which continent is about twice the size of Antarctica? Okay, well, first that means we gotta find that Antarctica. Where's Ant? Ant. 9%. Okay, well, 9%, twice, what does twice mean? That means times 2. Okay, well, what's 9 times 2? 18%. So we need to find which continent is about 18%. That means close to 18. Or exactly 18. Okay, so let's see. Oh, look, I think we have an exact 18%. It's Africa. Okay, let's go to part C. Part C says, how does Africa compare in size to Asia? Okay, well, Africa was 18 versus, what's the Asia? 27. So what can you say about that 18 compared to that 27? It's smaller. Okay? Part D says, which two continents make up about half of Earth's land area? Okay? Well, half of Earth's land area means 50%. Or as close to 50% as possible. So, what adds to 50? Or closest? There's not, we'll have to try. Okay, so, to get that, you look at the two highest. Because that's probably going to add to 50. So, let's see here. My highest is 27%. My other highest is this 18. If I add those up and down, let's see, we get a 5. We'll carry the 1. 45. Yeah, close enough. Yeah. Okay, so which two continents or whatever, yeah, add up to 50% of the land area? Well, it's Antarctica and Asia. It's not quite 50%, but in the word problem, it said the word about, which means it's okay if you're kind of off. So, part D is supposed to be Asia and Africa, because that's where our two biggest percentages come from. Okay? Part E says, what is the ratio of the size of Australia to North America? Okay, Australia is hit. And then remember, ratios, we put like a little colon. Yeah. Okay, North America is 15. But if you remember, ratios can also be fractions. Well, now that I wrote it as a fraction, we can see that it's not as small as we can go. So I need to not use this 6/15 or this 6/15. I have to try and make it go smaller. What can you divide 6 and 15 by? You can divide both of them by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. Or, now let's use the colons. 2:5. What? Okay, so part A was Asia. Part B was Africa. Part C was the word smaller. Part D was Asia and Africa. Part E is 2:5. 2:5. Okay, let's look at F. If Europe has approximately 3.8 million miles squared of land, what is the total area of land on Earth? Whoa. Okay, so we're going to use like a little proportion here. We're going to talk about Europe over all of Earth. Okay, so we're going to make two little equations, two little fractions, and in between there's going to be an equal sign. Okay, so first let's talk about Europe. It says if Europe has 3.8 million, well, I'm just going to write 3.8. Okay. It says, what is the total area of Earth? Well, we don't know that, so that's a question mark. Okay. Now let's deal with the percentages. What percentage was this Europe up in here, up in the chart? Europe was 8%. Yay. So I'm going to put 8 over here on this top right because it's the percent that's for Europe. It's the only other number we have. Okay, what about the percentage for Earth? Yeah, and remember, it's the total percentage. Well, what's the biggest percentage we can all ever have? 100. So, the 3.8 we got from the word problem. The 8 we got from the circle. The 100 came from, there's only ever 100% total, ever. We never go higher than that. Okay, now we're going to do cross multiply. you're going to multiply the diagonals that have two numbers in both. So 3.8 times 100. Then you're going to divide by the number in the diagonal that doesn't have a match. So we're going to divide by this 8. Hey, there's our answer. Let me write out how to do that long ways. We're going to multiply the diagonal with both the numbers in it. 3.8 times 100 divided by the number on the back end, the diagonal without matching numbers in both pieces. So find the diagonal without numbers in both matching pieces and divide by that 8. And we get 47.5. And then, remember how up here in the word problem, part F, it said 3.8 million squared? We need to tack that on. So this is 47.5 million square miles of land. Okay, let's keep going. A circle. Now we finally get to start talking about degrees. It says, in a circle graph, a sector containing 99 degrees represents which percentage of the data? Okay, well, we're going to do a proportion that we did this cross multiply and divide. The only thing we need to remember is how many total degrees are there in a circle. There's 100. There's 360. Okay, there's 360 total degrees in a circle. How many total percents are in a percent? 100. Okay, let's make a proportion. So this first proportion, it says in a circle graph, you're talking about a sector of degrees. Okay, but either way, we're talking about a sector versus percentage of the data. Okay, so versus the percent. Okay, and what we're going to do is we're going to do the part over the total. Okay, so first let's talk about this sector. Let's talk about it in terms of degrees. We're going to have two fractions with the part over the total. Well, how many degrees is this sector worth? It's worth 99, so that's the part. But how many total degrees are there? 360, so we put it over 360. Okay, then percentages. How much was this sector worth? What percentage? We don't know, because it says what percentage. So we don't know the portion, but we do know the total percent. The total percent we could ever have is 100. So to find this question mark, we're going to multiply 99 times 100 divided by 360. So 99 times 100 divided by 360. And real quick, you might be asking, could I have done a different proportion? Yes, you could have. You can take this proportion any way. You can take this proportion and you can rotate it in any way and it's acceptable. So let's say I rotate it this way. I can have 99 over 360 equals question mark over 100. So that's the original, okay? Or I could turn it like this and say 360 over 100 equals 99 over question mark. So this is another possible proportion. Or I could turn it this way and say 100 over question mark equals 360 over 99. Or I could turn it over again and say question mark over 100 equals 360 over 99. So all four of these options are possible. So if you wrote a different proportion than me, that's okay. We are all still going to do 99 times 100, 99 times 100, 100 times 99. Okay, or this one's wrong somehow. Forget about this one, not this one. Okay, not this last one. I screwed up. Okay, so anyway, it's okay if you have a different proportion than me. We have to be able to multiply the 99 and the 100. So whatever you're doing, the 99 and the 100 should be in the same diagonal. Okay, so when I do that, 99 times 100 divided by 360, bam, 27.5. So part A said, what percentage of the data is that? 27.5%. That's part A. Okay, part B says, in a graph, 0.70% of the data can be represented by a sector of how many degrees? Okay, part B, it's asking for different information. But we're still going to use the part over the total. Okay, so let's make up a percentage fraction. They told us 0.70 is the percent, so that's the part. How many total percent could there be? 100. Okay. Then it says it's represented by a sector of how many degrees? Well, we know that there's a total of 360, so that goes on the bottom. And then we don't know the degrees for that 70%. Now we're going to cross multiply and divide. Remember, you multiply the diagonals that have the numbers in both. So 0.70 times 360, and then divided by the number that does not have, divided by the number from the diagonal that does not have both pieces in there. And this one's going to be super small because it's 0.70%, and part A, we got a 27%. So it's okay if this answer is kind of weird. 0.70 times 36 equals divided by 100. 0.252. And this was talking about the sector as in degrees. Okay, let's keep going. Slide to the right. It says the following table shows the grade distribution for the final examination in the mathematics course for elementary teachers. Draw a percentage graph. Okay, to find the percentages, it's kind of like these proportions we've been doing. The part over the total, the part over the total. This frequency, we're going to call it the part. Now let's figure out the total. What is the total of all the frequencies? So let's add up all these frequencies, and we get 55. Okay, so now to find the percentages that we're going to use, we're just going to use the fraction part over the total. It's kind of like probability, kind of like those proportions. It all has to do the same thing. So for this percent, for this 5, we're going to say the part 5 divided by the total 55 and figure out what that is. 5 divided by 55 equals 0.09. Okay, but that's not a decimal. That's not a percentage. It's just a decimal. So to make it into a percentage, we have to move the decimale twice to the right to make 9%. Okay, keep going. For that 11, we say 11 divided by 55. And we get 0.2. But that's not a percent. It's a decimal. So let's move the decimal twice to the right. When I do, I get 20 and I need a 0 there. 0%. 20%. Okay, let's keep going. 22 divided by 55. That should make 0.4. And as a percent, you move the decimal to the right twice, and you got to slap an extra 0, so 40%. Then 12 divided by 55 is 0.21. Yeah, okay. So as a percent, move the decimal twice to the right, 21.8. And then the last sucker, 5 divided by 55, I think we've done that. It's just 0.09 or 9%. Okay, now let's draw a picture. Here's my circle. Don't judge me. Okay, and what's the highest percent? 40? Okay, well this whole circle is 100%. Half the circle is 40. Half the circle is 50%. Okay, well, we can't have all 50%, so we need a little bit less than 50%. So this would be 40%, or what letter was 40%? C. Okay, let's see here. There's a 20%. So that's like half of this guy. Who cares? This looks about right. 20%. This whole thing, 20%. And 20% is, what letter was that? B. Then it looks like we have another one that's pretty much the same size as that. It's a little bit bigger, and it's the D, and it's 21.8. And then what else do we have? 2 9s. So the 9% are A and F. Okay, my picture's not that great, but yours will be multiple choice and you can eyeball it. Okay, let's keep going. The next sucker we're going to talk about is a line graph. It's just a line with some dots on it. Alright, it says the graph shows how the value of a car depreciates. That means goes down each year. This graph helps to find the trade-in value of a car for each of 5 years. The percent given in the graph are based on the selling price of the new car. Part A, what is the approximate trade-in value of $12,000 car after 1 year? Okay, well first let's look for 1 year. Years are along the bottom. 1 is right here. Raise up. What percent do you have? Oh gosh. Let's see, we got to go from 60 to 80, so 62, 64, no, 65, 70. Yeah, I think these tick marks are different by 5. So we have 60, then 65, then the middle one is 70, and that's where we landed. Okay, but this is 70%. To figure out how much the car is worth, we're going to take this $12,000 and we're going to multiply it by that 70%, but move the decimal twice to the left. Or you could make a proportion. Just make sure you get the same answer as me. If you make a proportion and you don't get 8,400, try dividing by 100 or multiplying by 100. You probably got 84 somehow. Okay, so this is the trade-in value of a $12,000 car after 1 year. It goes down a lot. Okay, now it says how much has a $15,000 car depreciated after 5 years. Well, let's look at 5 years. Here he is. Go up and find the percentage. Oh gosh, help me. 20, 25, 30. Okay, I think that's 30%. Okay, so we're going to take that 15,000 and we're going to multiply by 30%. But we have to move the decimale twice to the left. So 0.3. Okay, and we get 4,500. Okay, so here's the thing. This 4,500 is not how much money we went down. It's the trade-in value. So, like on part A, it says the trade-in value is, and then we wrote the number that we got from the math. But here, it says the car has depreciated so much. So this is not the depreciation. This is not how much we went down. This is what they would pay us for it. So to figure out how much it went down, we're now going to take 15,000 and minus that 4,500. And that's how much the car has depreciated or gone down. And it looks like 10,500. So the trade-in value is 4,500, but the actual amount of money that our car lost was 10,500. All right, let's see. Step 3, it says, what is the approximate trade-in value of a 10,000 car? So let's take 10,000 and times it by, what does it say, year 2? Well, we got to find the percentage. Let's go look for year 2. Here he is. Find his percentage. Oh, help me. Okay, let's see here. 40. These go up by 5s. 45. 50. 55. Okay, I think this year 2 is at 55%. So we're going to take this 10,000 and we're going to multiply it by 55%, but move the decimal twice to the left to make 0.55. And let's see what this makes. This gives me 5,500. And again, this is the trade-in value. So that's my answer, 5,500. If it would have said depreciate, I would have taken that number I started with, 10,000, and I would subtract the trade-in. Kind of like on part B, it said depreciate. So I took the number I started with, 15,000, and I subtracted that trade-in value. So that's what I do if it says depreciate. You gotta subtract. Okay, part D, it says Danny wants to trade in her car before it loses half its value. When should she do this? Oh, okay. Well, what is half of its value? We don't know what it started with, but we know if you lose half, how much percent do you lose? You lose 50%. So, to figure out when that happens, we're going to look for 50% on the up and down. Yep. And then the answer is the year from side to side. Okay, well, let's go. Let's look at my picture. Here's the picture. We got to find 50%. Oh. Okay, let's see. 50%. 50 is halfway in between 40 and 60, so... no, it's too small. Yeah, this looks like it's about 50%. Where's it at? 50% right here. 50%. It's 50 high. Yeah. Okay, the question is, what is the amount of years right here? Well, it's halfway in between 2 and 3, so maybe 1.5-ish. Close enough. Okay, so Danny wanted to trade in her car before it loses half of its value. Well, half means 50%. So I looked for 50% on the up and down, the y-axis, and I found it. And then I had to figure out what my x-axis number was. And we kind of rounded. Oh my gosh, I can't even count. Halfway in between 2 and 3 is 2.5. Golly. It's like 4 p.m. and I've done math all day. I'm saying everything wrong. Okay, last sucker. Consider an arithmetic sequence with first term of 5 and difference 2. Okay, don't panic. Okay, this says first term 5. With a difference of 2. What does difference mean? That means minus. So the next number is 5 minus 2 is 3. Arithmetic just means you get each number by doing some easy math. Okay, minus 2 again. 1. Yeah, you get the point. Blah, 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 blah. Okay, it says plot this sequence on a scatter plot. What? That's crazy. Alright, a scatter plot means that I graph my first number as a 5. So I go to the right 1 and then up 1, 2, 3, 4, 5 and draw a dot. Then that second number in the sequence is the second number. So I go to 2 on the x-axis, 2 to the right, and then go up however much that number was, 3. Okay, then your third number means you go to the right 3, and then you go up however much that number is I'm pointing at, and it's 1. So we go 1 high. Hey, this is my scatter plot. Okay, so your first number is like saying to the right 1 and then up however much that first number was. To get to the second number, remember we had to minus 2 every time? So since that's the second number, I'm going to pretend it's like 2, 3. 2 to the right, 3 up. Okay, trend line means draw a line through those dots. Hey. That's true. Alright, that's part B, that diagonal. Part C says something about a equation. Okay, well this kind of seems terrifying, but it's okay. It's going to be y equals mx plus b. And m is whatever you minused. What? 2. Okay. You keep the letter y there. Y equals. You keep the letter x there. And then b is whatever you think the b would be when I continued my line. This B means what you touch on the up and down axis, or another way of saying that is your y-intercept. So this B is asking you, hey, if I drew this line, okay, where would this line cross this up and down axis? And you might think, how the heck am I supposed to know that? Well, you just keep minuses only in the backwards direction. See how these y values are 1, 3, 5. What's the pattern? Like you add 2? Yeah, okay. So what would the next number be? 7. Hey, you just found where that line would cross. So you just use the pattern. Only it's kind of backwards of -2. We go up. So 1 plus 2 is 3. Plus 2, plus 2. You just use that pattern. Okay, so where did we cross that up and down line? We crossed the up and down line at 7. Hey, that's your equation. So part A is this picture without the line. Part B is this picture with the line. Part C, you take the 2 from the word difference and you put it in the M. Then you keep extending the line and see where that sucker would cross that up and down axis. And that's your B. Okay, we're done with 10-point all of this. This was 10-2 and 10-3. Woohoo!